Hello, for this trial we're going to make just one small tweak to our last setup. Basically I'm just going to expand the time interval so that we can see the motion up the hill and then back down the hill. We'll see what that looks like. Okay, and we get a nice graph out of that. Okay, so you see the initial graph right here, our position over time graph, it starts with some positive velocity and then it's decreasing, and then this apex is when it actually slows down and stops. And then it accelerates back toward the reference point. So we see a negative slope, meaning the distance is decreasing. Over here, it's positive slope, meaning the distance is increasing. And then it's decreasing distance here, and it's decreasing at a faster rate, okay? So as it goes down the hill, it's getting faster and faster and faster, and that's why that slope is increasingly negative, okay? Now with the acceleration graph, we also see a nice constant slope there, okay? The slope, again, of a velocity over time graph is acceleration. So what this negative slope on our velocity versus time graph is telling us is that our acceleration is completely constant. Don't worry about this part on the edge. That's where it stops at the end when it hits the detector, okay? This point right here is where it's at the apex, where it's basically changing directions, okay? Above the x-intercept is when it's moving away. Below the x-intercept is when it's moving back toward. So we see moving away at a decreasing rate and then moving toward at an increasing rate as it goes down here. And then we get a bunch of just randomness at the end of the trial.